Hi, welcome to the Calculus 3 assignment practice series. And we are still in the unit, Vectors and the Geometry of Space. And today we are going to take a look at assignment number 5. And in this assignment, we're going to find the equations of the lines and the planes in the R3 dimension. So we're going to go to our worksheets. And I probably will work, I think 7 or 8 problems in the worksheets. Okay, so let me go to here. Okay, so the first problem we're going to work is kind of like the concept problems here. I think it's kind of like a very important problem to clarify our concept. Okay, so let's take a look at the two lines. If they are parallel to a third line, is parallel, is it true or false? This is true, right? Because if the two lines parallel to the third one, then these two has to be parallel to each other. Okay, part B is here is the two lines perpendicular to a third line. Are they parallel or not? And this is a false because in the space, right? If you have like a line here, imagine this is in the R3 space, right? So if this is the lines here, right? So you can have one line go here, like a perpendicular to this way. Then you can go another way here, maybe like go this one. Then this is perpendicular to this also, but these two are not. Right? It's hard for me to draw in here, but if you can, do a demonstration by yourself, and then you will see that. So it's not, so it's a false here. Okay, see here, the number C here, two planes parallel to a third plane, they are parallel, that's true. And the part D, two planes perpendicular to the third plane, they are parallel. Is this one true or false? This one is false here. Okay, the reason why this false, let me erase this one here. So let's take a look. The reason why this one is false, because I know the XY planes, right? So in the R3, the XY plane is perpendicular to what? XZ, the XY plane is perpendicular to the XZ planes, right? Right? And then the YZ plane is perpendicular to XZ planes also, right? But I know the XY plane is not parallel to the XZ plane, YZ planes, right? So XY plane is not plane, perpendicular to the YZ planes here. So that's why, when the two planes are perpendicular to the third one, doesn't mean these two planes will be parallels here. Okay, so the part is here, they say two lines parallel to a plane are parallel. So this is false here. The reason why it's false here, because in the R3, right? So think about here, if you have a plane here, and then one line can go like this, right? So on top of this plane here is a parallel. Then the other line can go below the plane. It's like go this direction. So then these two, they are not parallel, right? So that's why E is false. F here, so they say two lines perpendicular to a plane, they are parallel. This is true because we know a plane is uniquely defined by its perpendicular line. That's the normal vectors, right? Okay, G is here, two planes parallel to a line, they are parallel. Two planes parallel to a line, then there has to be parallel. So this is true or false, this is false here. I can give you an example why this one is false here. Okay, so let's take a look at why this is false here. All right, so like for examples, right? And so I said, y, if you have like a plane y equal to 1 and z equal to 1, right? So this is like the planes here. One is like, kind of intersect y at 1, and then the other ones here is kind of like a plane. You intersect Z at once here, right? Both of those two planes, they're parallel to what? They're parallel to the x-axis. But you see these two planes, they are not parallels here. Okay, so part H here, two planes perpendicular to a lines are parallel. That's true because we know a plane is uniquely defined by the normal vector. Okay, two planes either intersect or parallel. That's true. There's no other ways, right? That's true. Then the J's here, they said two lines either intersect or parallel. But here, this is false. Why? Because we could have a skew, right? The skew lines, they are not parallel and not intersect, right? So just like a one line go like this direction and other one go like this directions, right? So they probably, so they are, I'm sorry, not to go this direction. So in here, like if one lines go in R3, go like this way, then the other one, they can go like a similar, the same, go like this way, maybe below that. They are not parallel, they're not intersect. Okay, so then the case here, a plane and the line either intersect or are parallel. That's true? Yes, that's true here, right? So this one's false here. Okay, so that the first problem is a pretty good problem. It's kind of like a concept problems, right? So, okay, let's start with some easy problems here. So we said the line goes through 2, 1, 0 and the perpendicular to both. As soon as I see the perpendicular, what's that mean? That means what? The cross product, right? Okay, so that means, remember, every time do a line, we need to have a directional vector and a point, right? So the directional vectors here will just be the I plus j, what? Cross j plus k's, right? Because that's what is the properties about the cross product here. So let's see here. So this is I, j, k. And I plus j is 1, 1, 0, right? J plus k is 0, 1, 1. And I assume we all know how to do the cross product right now. So this is the I minus j plus what? Plus k. So this is our directional vector. So if you write it into a parametric form passing through this one, so it's x what? X equal to the 2 plus 1 times t, y is equal to what? Negative 1 minus here, right? Minus t, and the z is 0, so it's 0 plus t, so it's z equal to t, right? So this one is pretty straightforward, okay? Let's take a look at number 15 here. Number 15, they said, okay, find the symmetric equation for the line passing through the point, 1, negative 5, and 6, and parallel to the vector. Okay, so the parallel to the vector, that means what is the parallel means? That means this is what? This is my directional vector, right? Because that means this is a directional vector. So every time if I have a line, and in order to find the line, if I know the directional vector, I know the point, I can do that. And so in here, they wanted to find the symmetric equations here. So, okay, so let's try to write it. So what is it? So I have a point, right? So this will be x minus 1. So what is directional for the x is negative 1, right? Is equal to, then y is negative 5. So it's y plus 5. What is the directional for the y? It's 2. And then here, so this is a 6, right? So it's z minus 6 here. Okay, so the z minus 6. And what is the directional? Negative 3 here. Okay, so the reason why I choose these problems here is because they do ask, they say, hey, find the point, right? So this, this line intersect the coordinates plane. right? Okay, so we have 3 situations. So the situation number 1, let's say here, how about if this point, this line intersect, okay, so intersect, so it's the intersect xy plane. So if this is the intersect xy plane, so what does that mean? That means my z equal to 0, right? So then you plug the z equal to 0 to here. That's what you get here. So you have x minus 1, negative 1 equal to y plus 5, 2. So z, you put the z equal to 0. Okay, so like in here, you put this one equal to 0 here, right? So it's 0 minus 6, negative 6, so it's a 2, right? Okay, so now, because of this, you can solve it. So x equal to what? X equal to negative 1, and y equal to what? Y equal to 1, right? Okay. Y equal to negative 1, I'm sorry, negative 1. Okay, so the first point here, this will be negative 1, negative 1, 0, right? So also the line could intercept, right, intersect YZ plane. So when the x intercept the YZ plane, what's that mean? That means x equal to 0. Right, so when the x equal to 0, that means the y plus 5 over 2 equal to z minus 6 over negative 3. So when the x equal to 0 here, right? So this is 1, right? Okay, so now this is equal to 1, right? So what is the y here you have? So y will be negative 3, right? Okay, and then what is z going to have? Z going to have a positive 3. So for these points here, my is what? So what is my answer? Is 0, negative 3, 3, right? So the last one, this one can intersect what here? XZ plane, correct? Okay. So when the xz plane, I will set the y equal to 0. Okay, so when you set y equal to 0, that means x minus 1, negative 1 equal to z minus 6, negative 3, y equal to 0 is 5 half, right? Okay, so now we can solve it. We can say x is equal to negative 3 half and z equal to what? Z equal to negative 3 half also. So this point will be negative 3 half, 0, negative 3 half, right? Okay, so that is my solutions here. Depends on the different, the plane, the coordinate plane you intersect here. So those are the points. So the reason why I want to do this problem is because I want to show you how to find the point when they intersect the coordinate plane. Okay, so now let's go in down here. So the next problem I want to do is problem number 30 here. Okay, so for the problem number 30, it's tell you the plane have the line. So this line sit on top of the plane. So it's x equal to 1 plus t, y equal to 2 minus t, and z equal to 4 minus 3t. And this plane, okay, going to parallel to the plane 5x plus 2y plus z. Okay, so every time, remember, right? So this one, they give you this plane here. So I know for this plane, what is my directional vector for this planes here? So that I'm not sorry, it's not a directional vector. Those are the value for my what? For my normal vectors, right? So the normal vector for this plane will be 5, 2, 1, correct? And so this is the plane. So this is the vector perpendicular to this plane. But this plane have this, okay, so this plane have this line. So from the line, I know the directional vector, right? So this is the directional vector. Okay, so what is this directional vector? This directional vector is the constant in front of what? The constant in front of the t's. here, correct? So the directional vectors here will be 1, -1, and the -3, all right? So this is the one, and then we know if these two planes are parallel, so this plane must have a perpendicular normal line also. So since this is on the plane, so this normal has to be the same normal line like on this plane. So then I know that n dot v is equal to what? Equal to 0, because these two, right? These two has to be perpendicular here, correct? Okay, so when this two is perpendicular, then I will say, okay, so that's why, you know, we have used the normal, so we can use these normal vectors as the same normal vector as the plane we're looking for. So now I can find a point, right? So if I need to find a point, right? So then I can use the plane, the formulas here. So I say, hey, let's say I can find anything I set a t equal to 0. So if your t equal to 0, what is your, here is your 1, 2, and 4, right? So this is the point, right? So I find the point 1, 2, and 4 on the plane. Okay, so for this plane, I know the point, I know the normal vector. So how do I write these planes here? So I will say phi x minus 1 plus 2 y minus 2 and plus what? Phi 2 1 plus 1, right? Plus 1, okay, z minus 4, right? And this is equal to 0. Or if you want to simplify, you can find it's 5x plus 2y plus z is equal to 13. All right, so that will be the answer. That will be the planes here. So remember, right, the plane is uniquely defined by the normal vector. So we need to find the normal vectors. That's an end because they are parallel. So the normal vector for this plane is the same the normal vector from the one there. Okay, so then next one we're going to work is problem 35 here. Okay, so this is the very similar problems, right? So this plane passing through the points and have the lines here. So I'm finding the plane. So basically this is my planes here, right? So in this plane, so we say, okay, so it's include this line and also have these points here, right? Okay, so how do I find the planes here, right? Okay, so now the first thing is because these lines here, right? So I know the direction because the directional vector will be the constants in front of the t. So what is the directional vector for these lines here? The v will be what? -1, 2, and the -3, correct? Okay. Okay, so now I'm going to find a point, right? So find a point on the line, see here. So I'm find a point on the line. So any point, so I will say, hey, let's t equal to 0. Let's try to find a point. So the point on the line will be 4, -1, and what? And the zeros, right? Okay. So now in the 0. So now you will see why I want to find this point. Okay, so because this point is 3, 5, -1. And this point I just find is the 4, -1, 0. So I can connect this, right? So this is, I call this the B, and this is my A. Why I want to do that? Because in order to find the plane, I need to have what? I need to have the normal vector. How do I produce normal vector? I need to find a vector is perpendicular. So that's what I need to do. I need to find the two vectors and then I cross product that to give me the normal vectors, right? So now, okay, so now I can say, okay, then my B vector will be, connect these two, right? So it will be like a 4 minus 3, okay, and then -1 minus 5, and 0 minus -1, right? So this B vector going to be 1, -6, and 1. Then for my A vectors, right? So because this is my directional vector, so I know these two, right? So this is the directional vector, right? So for the red, you know, is a pair. So the directional vector, this is -1, 2, -3. So what is my normal vector right now? So my normal vector, right, will just be equal to what? Will be the -1, 2, -3 cross what? Cross 1, -6 once, right? Because I know if I cross product, I get a perpendicular vector. So now I get here, this is, I hope it's, you know, I did it right. So this is -16, -2, and 4, right? So this will be my normal vector. So after you find the normal vector, then the line is pretty easy. You have a normal vector, you have a pointer, okay? So it will be -16. So this is x minus 3, correct? Then minus -2, so this is y minus 5, right? Then plus 4, then this is what? So 4, this will be z plus 1, right? Because it's -1 here. So this is equal to 0. If you want to simplify it, you will get this is ax. You just use the distributive property and simplify it, right? So it's -2z equal to 31. Okay, so that would be the answers here. Okay, so it's kind of fun, right? Okay, let's take a look at the next one. All right, so this is number 38 here, okay? So let's see here, what do we need to do? So remember, when you do the plane, you need to find the normal vector. So they said, okay, so with the plane that are passing through the points 0, 2, so that means this plane have these 2 points. And these 2 points will define a line, right? So we'll define the what? The directional vector. So I know I can define the, right? So I can define the directional vector will be what? Will be 0 minus 1, -1. So 0 minus -1, then -2 minus 3, then 5 minus 1. So what is here? I have a 1, right? -5 and 4. So this is my directional vector. And then they say, hey, you know, this plane has to be perpendicular to this plane here, okay? So for the perpendicular to this plane, and then that means in here, for this one's here, okay, so let's try to take a look at this one. So this one's here, this is 5x plus 4y and equal to -2z equal to 0. So we know, okay, the front here, those are the normal vector. Those are the normal vector for this planes, right? So this is the normal vector. It's a 5, 4, -2 for this plane. But the plane we are looking for is perpendicular to this plane because normal vector is perpendicular to this plane. So the plane we're looking for, so what's that mean? That means I get another, so the V2 for this plane is what? Is a 5, 4, -2. That means I have another, this is V2 in this plane. It has to be the same as the normal vector because this plane is perpendicular to the given plane. And I know the normal vector is perpendicular to that plane here. So that's why this will be my V2 and this is my what? And this is my V1s, right? Okay, so now I have V2 and V1. So in order to find this given plane, what I need to do, I need to have a normal vector. So how do I do the normal vectors here? So this is a normal vector will be V1 cross V2. So then you use the cross product, and then you can find the normal vector. This is 6, negative 22, and the negative 29. So this is the normal vector for the plane we are looking for, right? We are looking for, right? So this is the plane. Okay, so now I have a normal vector. I have a point. Then I can find it, right? So this is will be 6. I can use either this one or that one. So I say x minus 0 minus 22y plus 2, right? And then minus 29z. So it's z minus 5 equal to what? Equal to 0. If you want to simplify it, and you will get this is a 6x minus 22y minus 29z is equal to the negative 101. Okay. All right. So now let's take a look at our next problem. Okay. So the next problem here I like to do is problem 76 here. Okay, so for the problem 76, I need to use the result of the problem 75. I would like you to show the problem 75. So let's say if the distance between the two parallel lines is basically you just square the coefficient and then you find the differences here. Okay, so now let's take a look at problem 76. It said find the equation of the plane that's parallel to this plane. Okay, so these planes here, the parallel, that means they're going to share the same normal vector. It's 1, 2, negative 2, correct? And let's say yes, 2 units away from that, right? It's 2 units away. So that means I know the plane I'm looking for is what? Is something like here is x plus 2y minus 2z equal to what? Equal to some constants k. But it's 2 units away. So that means by using the distance here, so this is 2, then this is 1 minus k, right? Now bottom here will be the factor, the length of your normal vector. So it's 1 plus 2 square plus 2 square. So that means 2 is equal to 1 minus k. And 4 plus 4 is 9, so it's 3. So that means 1 minus k equal to 6. So you solve the absolute value, and I can get a k if the k equal to 7 will work, or k equal to negative 5, right? So I have 2 planes. So one is x plus 2y minus 2z equal to 7, or x plus 2y minus 2z equal to negative 5. So both of these planes are 2 units away from the given one here, right? So if you apply the formula for the number 75, it will pretty easy to solve it. Okay, so now let's take a look at the last ones here. Okay, so this one is very interesting. So this ones here is, they say, hey, I have 2 skew lines, right? I want to find the distance between these 2 skew lines here. Okay, so if this is 2 skew lines, right? Okay, so the first lines here, let's say this is the one, let's color coding that. So the directional vector for this one, what is that? Is the constants in front of the t. So will be what is 1, 6, and what? 2, right? And now you have the second ones here. So second lines here, the constants is what? Is 2, right? 5, 2, 15, and the 6. So this is the directional vector for the first one, and this one is the directional vector for the second line here, right? So if you put if you put the planes to each one's here, so it turns out the normal vector for the planes here is going to be, so these two lines, will form the normal vector. So the normal vectors will be the V1 cross V2. So the normal vector you form that it will be the normal vector, for the planes here. Okay, so for both those two planes contain the line. So here the normal vector will be 6, -2, and 3. Those are the normal vectors here. Okay, so that means in here, if you put so you have two planes here, right? So one plane have this line, one plane may, including these lines, right? So it's on the plane, and other planes, they have like this line on the planes here. So they are not parallel, they not intersect, they are skew. And now in here, so, but both of them was the normal vector is the same, right? Okay, so now they said, what is the distance? So as long as I can find a point, then I can use my previous, I can use my previous number 76 to find it, correct? All right, so now in here, I say, okay, I'm finding the point. So I said here, okay, I say here, for the first planes here, right, I let the t equal to 0 to see what is the point. So the t equal to 0, this will be 1, 1, 0, right? That's 1, 1, 0. Then, so that means in here, I find the point. This is 1, 1, 0. Then for the s equal to 0, I can find this is a point. I have 1, 5, -2, right? So this is my another point. This is 1, 5, -2, right? Okay, so then you put them. Okay, so now you put the names into the, so because of the normal vectors, right? So you put the name into the equations here. Let me get a little bit of space here. Okay, so okay, now for each one, you have a point and you have normal vectors. So the first, first plane, it will be what? Will be the 6x minus 1 plus, so not plus, so it's a minus, right? So minus, I'm going to erase that good. Okay, so, okay. So minus 2, right? 2y minus 1, then plus 3z equal to 0. Then the second one is here. You can say this is 6x minus 1, then minus 2. So this is y minus 5, then plus 3z plus 2 equal to 0, right? And now you simplify that, and then you can find this equation will be the 6x minus 2y plus 3z equal to what? Let me erase here so I can have a little bit of space here. Okay, so here you will get this is 6 minus 2y plus 3z. So this will be equal to what here? -4, right? So then this one's here, you will be 6x minus 2y plus 3z. And what is here you're going to have? You're going to have -10 here, right? Okay, so now, because now I can know the distance between these two skew lines will just be the distance between these two planes, right? So the distance will just be, so here this is 6 to the square plus -2 to the square plus 3 to the square. Then the top, we just minus these two, right? So it's -4. Okay, so here, let me see here. So, oh, this is +10. So it's -4 minus 10 here, right? So it turns out pretty good. The answer is 2. All right. All right, that's it. And the problem number 78 is kind of like the very good problems. They want to find the distance between the skew line. That means, you know, that's the trick here is you need to find is like, so for each line, you can fit a plane, right? Now, after you fit the 2 planes, then you know these 2 planes, they're going to be parallel. Then you can use the distance between the parallel planes to find the distance between these 2 skew lines. Okay, that's it. And I think we did a lot of problems in this assignment. So I hope that you can get a good understanding for the, you know, for these units here, how to write the equations of lines and the planes in the R3. Okay, that's it. And you guys have a nice day, and looking forward to talk to you again in our next lecture series, number 6 here. Okay, bye.